As we were working on parallelograms today, I wanted to take a minute just to walk through some of the potential problems that we have on today's assignment. These are compiled from our textbook. And so looking at this, starting right off the bat, I went ahead and put in the parallelogram so we can identify some stuff based on its properties. So if ABCD here is a parallelogram, things that we know, properties of parallelograms, is that my opposite sides are going to be parallel. Some other things that we came up with, the opposite lengths, opposite sides are going to be congruent. The diagonals are going to bisect each other, and that means that in this case, AE is going to be the same length as EC, and BE will be the same length as ED. And of course, since they bisect each other, that point E is going to end up being the midpoint of both BD and for AC. Some of the characteristics. Okay, let's see. Angle-wise, we also have some information that we can glean here. Just remember here we have two parallel lines cut by a transversal. So what it turns out is that angle ABD here is going to be congruent to CDB, and angle ADB is going to be congruent to CBD. And as we work our way around, we know that this angle ACB is going to be congruent to CAD. And then finally, we have this last angle is going to be congruent. Last sets of angles are going to be congruent. So those are based on parallel lines cut by a transversal. So we can look here and we can see that it turns out if I have side angle side, side angle side, I have two congruent triangles, two sets of congruent triangles, because here I have angle, side angle, angle, side angle. So again, we've just created two things of congruent triangles. So we could go back and fill in our examples over here, 1, 2, and 3. But just knowing that these are things that we can use, these properties. One other thing that we didn't mention here as part of the properties is that we have encountered, we do have two parallel lines cut by a transversal. So understanding that, our consecutive interior angles are going to be supplementary, or they're going to add up to 180 degrees. So overall, angle B and angle C add up to 180 degrees, and we also can recognize that angle A is going to be congruent to angle C, and angle D is going to be congruent to angle B. Okay, so there you go, some of the things that we learned. So here, looking, I don't even know, I'm not even going to read any, looking at some of this stuff going on here. If this is a parallelogram, I should be able to quickly label that my opposite sides are congruent, and then my consecutive angles add up to 180 degrees. So if this is 67, this over here should be 113 degrees, and of course 67 and 113 degrees. That's just the properties of parallelogram. As we go through more of these examples, I'm looking here, it says using example 3, find the value of each variable for each parallelogram. Well, again, using these characteristics, these properties, I should know that, let's see here, this is a midpoint, so this segment is equal to this. So I could say that y minus 7 is equal to 10. I should be able to tell that this segment is equal to this segment, so I should be able to solve by saying x plus 6 is equal to 11, and continuing on to solve for both x and y there independently. I'm just slapping through a couple of examples here. I know that my opposite angles are congruent. So angle G is going to be congruent to angle J. So their values are going to be equal. So my measurement of 4B is going to be equal to 56. And then that allows me to solve for that variable. And of course, my opposite sides. This side is going to be congruent to this side is going to be congruent to this side. So there again, I can make up my equation by saying that 3y plus 13 is equal to 22. 2x minus 3 is equal to 21. And there you go. I'm using some of those properties to build these equations. More equations going on back here, doing the same thing again, that this angle plus this angle should be equal to 180 degrees because they are consecutive interior angles. I can solve for x that way. Coming over here, I have another parallelogram. I know this diagonal is going to be equal to this diagonal, so 12y plus 3 is going to be equal to 21. Little things, little things. Looking here, example number 4, number 18 for the dog park. The new dog park is being designed by a city planner. The park is enclosed by a fence going around it, shaped like a parallelogram. What is the area and perimeter of the dog park? Round your answers to the nearest hundredth. Okay, so area and perimeter. Let's see, well, I know that this length is equal to this length is equal to this length. So when I go to find area, I should be using the distance formula. I can use the distance formula for this side. I can use the distance formula for this side, and then of course the other opposite sides are going to be the same. So there you go. That's one way I can do it. I can also, when I'm looking at area, I could deconstruct this and say, hey, technically I have two triangles. And I could go ahead and calculate those two triangles using 1/2 base times height, and add them together and come up with the area. Or I could possibly work out the height of my parallelogram. It just depends on what you're comfortable with, but that should give you a lot of good examples and good steps to build on that will allow you to do today's assignment.